Excellent. Let's move this one. Just put it here somewhere so it doesn't block the page. Okay, so everybody hear me, right? Yeah. So automatic reference counting, or ARC, basically. So so it's a memory management in Swift. So and as far as I remember, it was introduced basically like not just Swift, like a Swift and Objective-C and all that. So and it was introduced, I guess, Objective-C version 4 or 5. So before that, many thing was like a manual. If you see very legacy old Objective-C code, you will see a lot of keyboard like retain, copy, strong, weak. Many of these basically in the code that show that the user or the developer was responsible for taking care of memory management, when to allocate memory, when to release the memory, when to free them, make sure that the memory management is done properly. So but automatic reference counting, and it says it's automatic, so it's done by Swift for us, but not everything is done by Swift. So as a developer, you're also responsible for contributing into this process. Let's see what it is. Again, this is an important topic, particularly when it comes to, of course, understanding how the language works, but also always there's a question about that in interviews. So I think that this is 24 page. I just want to talk about some part of it, and we'll continue next week with that. So so the job of automatic reference counting, as you can see in here, is free up the memory used by class instance when those instances are no longer needed. Again, remember, it's a reference counting, and whenever you see the word reference, we're talking about reference types. So here we don't care about the structure, we don't care about enumeration, enums, because they're value type. Here we're talking just about classes and closures, because those are the two reference types in Swift. So how it works, so as I have highlighted in here for you, so every time you create a new instance of a class, Arc allocate some memory for that, and then when you and of course the memory keeps all the information about the content of that class, of that instance, and when you basically that object is not needed, the Swift is responsible for free up that location of the memory. If it doesn't do that, if you keep your application running, you will see, it will keep like occupying more memory. And because, the quota for your memory is allocated by like iOS, when you run the application on your phone or on your computer, you have some, some amount assigned to you. And if you go above that amount, then your app will be automatically shut down. So this is what we call memory leak. The memory doesn't get free up, and then you'll see the more you use the app, the amount of memory it uses is just going up. So when you profile your app, you can see that this memory like amount is just increasing. While in a proper app, for instance, when you go to a page and you download many things, or you have a lot of objects created, you will see the memory goes up, and when you leave that page again, everything is freed up, and again the memory come back down. So this shows that it doesn't have a memory leak problem. So but let's see basically how it works. So the mechanism is pretty simple. It's based on what we call a reference count. So whenever whenever you assign a reference or a property to a class, or assign an instance to a property or an instance to a variable constant, you're basically creating a reference to that location of the memory, or to that instance. In other words, a reference says how many people are interested in this data in this location of the memory. So every time you assign it, the reference count, which starts from 0, is going to be increased by 1. So if there's only one property assigned to this instance, then the reference count for that instance is 1. And again, the releasing mechanism is also easy. Once the reference count becomes 0, then the Swift will automatically free up that location of the memory for you and make it available to use by, by your app. So therefore, this is the mechanism how the reference counting works. It's based on the simple mechanism called reference count. So reference count increases anytime you assign a property, a variable, a constant to an instance, and whenever you remove that, the reference count decreases by 1 unit, by one number. So let's see. Just move on. Let's just look at some, example in here. Look at the class person, for instance. You have the class person with some property like name, initializer, and deinitializer. So this is the deinitializer is called automatically. So you're not supposed to call that. So it's called automatically when the instance gets deallocated. I mean, when the memory is going to be released for being used by other part of the app. Let's say we define some reference to person. The reference 1 is of type person, reference 2 is of type person, reference 3 is of type person, again, optional person. So you create, let me just move this from here so I can see that. It creates, you just use the initialize of the person, and you create an object from person, and then you assign this instance to reference 1. So right now, reference 1 is referring to this location of the memory or to this instance of person. So therefore, the reference count for that location of the memory is 1, because that means one person or one reference or reference 1 is interested in the content of this location in the memory. So, and if you call, let's say, reference 2 equal to reference 1, you're adding another reference referring to the same location of the memory. So therefore, the reference count RC of this instance becomes 2. And when you say reference 3 equal to reference 1, then you're adding another reference to the same location of the memory. So therefore, the reference 3 is equal to 3. So in order to decrease, then this reference count, you need to assign nil to those references. When you say reference 1 equal to nil, the reference count becomes 2. It used to be 3, now it becomes 2. So reference 2 equal to nil, then it becomes 1. And then when you say reference 3 equal to nil, then the reference count for that location of the memory becomes 0. Therefore, it's ready. You don't know when this is going to be deallocated, whether it's right away at that time that it becomes 0. And we don't also care. And we cannot really control that. So Swift behind us, it will take care of it for us as long as the reference count is 0. So let's see, when we have something, how the problem happened. Look at here, one example in here. So we have the class person, and then we have the class apartment. Within the class person, we have like a property of type apartment. That means a person can live in an apartment, which is an optional. That means, they could be null at some point. And also within the apartment, we also have a reference to the person. That means the person who lives in that apartment. Of course, an apartment doesn't have to be always occupied. So therefore, the person could be null. So that's why the person is also optional. So again, this is an example of when two classes are going to communicate with each other. And these two are passing mutual, like a reference to each other. Again, which is, as you can see, is not going to be a good practice this way. So person has a reference to apartment, apartment has a reference to person. So, so let's say, we define one reference called John of type person and unit 4A of type apartment. Then we create an object from person, and we assign it to John, and we assign a reference from apartment, and we assign it to unit 4A. So John right now is a reference or a strong reference. When I say reference, I mean a strong reference. John is a strong reference to this location of the memory, which represents a person instance. As you can see, John here is a reference, is a strong reference to this instance of a person. Similarly, unit 4A is also a strong reference to this apartment instance. But also, because a person has an apartment, is right now nil, right? Is right now nil because we haven't assigned it yet. And also the tenant of type person is also nil. Then, at some point we write John, we unwrap it, dot apartment equal to unit 4A. So we create another strong reference to unit 4A. And then in unit 4A, we also set the tenant to be equal to John. So therefore this tenant is going to also create another strong reference to this person object or instance. This is what happened. Right now, the reference count of this location of the memory for person instance is 2, and the reference count for apartment instance is also 2, because there are 2 strong references to each of these. Then, okay, everything seems good so far, right? This is pretty much, if you see this code, and if you are not familiar with this concept of memory management stuff, it seems good. It's normal. So you just assign, assign some values to some properties. Then at some point in your program, maybe when you are done with John and unit, you want to assign it to null, with the hope that this is all fine. So you write John equal to null. So this John equal to null. That means you basically break this strong reference from John to this instance. And unit 4A is also equal to nil. So also you break this strong reference from unit 4A to the apartment instance. So the reference count for the apartment is now 1, and the reference count for the person instance is also 1. But because you have already set John and unit 4A equal to null, then you have no access to these 2 instances anymore. There's no way for you to get to these 2 properties. So this is when these two locations in the memory are not going to be freed up. They are not going to be released, because the reference count to them is 1, and there is no way that we can it could be set to 0. There is no way for us to break these 2 strong references, and this is what we call return cycle, or this is what we call basically a reference cycle. So there are 2 strong references to each other which keep each other alive. And if it happens, if you run the application a few times, such things basically will be created a few times. You will have like tons of this like this situation, and it just start wasting your memory. And at some point, you ran out of memory, and then your application is shut down by the operation system, by the OS, by the iOS OS. So, but what is the solution? The solution is, does that make sense so far? How the return cycle happen, or reference cycle happen. This is between 2 classes. So we will see later on, next week. This also happens between a closure and a class. So that's why that all those return cycle happen for the closure as well, which is very important to know how it happens, because it's easy for people to make mistake when we work with closure and create just return cycle, and therefore create memory leak in your application. But here between 2 classes as 2 reference type. But what is the solution? The solution is basically define what we call either an unowned reference or weak reference. So Swift has basically 2 mechanisms. One is weak reference as opposed to a strong reference, or unowned reference. So sometimes you use weak, sometimes you use unowned. We'll talk about it later again. So let's see how the weak reference is solving this issue. The difference between a weak reference and a strong reference is that a weak reference also creates a reference to an instance. That's only like a difference. It also creates a reference to an instance, but it doesn't add or it doesn't increase the reference count of that instance. So this is how it's helping with this return cycle problem. Even though a weak reference creates a reference to an instance, but it doesn't add to the reference count of that instance, as opposed to a strong reference. A strong reference also creates a reference to another instance, but in addition to that, it also increases the reference count. So for instance, you have person, you got apartment, and for apartment, you have tenant, and you define tenant to be a weak reference. So like whether you put weak here or here, it doesn't really matter. but usually, you know, you can have an apartment with usually you put the weak which to the reference that is weaker basically. That means, you know, you can have an apartment without a person, right? You know, apartment can be like no tenant in it. But usually, you know, when you have a tenant, that means there's an apartment assigned to that. But again, or even, you know, you don't, you know, even you can think of, you know, one of them live shorter than the other one. Whether you can say, no, yeah, I have a person with no apartment. Yes, it also makes sense. Or you can have an apartment with no tenant. It also makes sense. So you put weak for one of them. And what happened is that you're still the same situation. You still have John of type person, unit for A of type apartment. You create two references. So John equal person, it creates a strong reference. Here there is no weak, right? There's no weak in here. So it creates a strong reference from John to that location in the memory, and also from unit 4A, create a strong reference to the unit. But once you assign apartment, the tenant, from apartment to, sorry, from the person to the apartment is a strong reference, right? From, look at here, from person to the apartment, here is a strong reference, but from apartment to the tenant is a weak reference. So this situation here is weak. So therefore, the RC, or the reference count for the apartment, is 2, right? Because there are two strong references to the apartment instance, but the reference count for the person, or for this location of the memory for this person instance, is 1, because there is one strong reference and there is one weak reference to here. So how does it help? The way it helps is that, let's say you assign John equal to null. When you assign John equal to null, basically you are breaking this a strong reference, right? You know, so John equal to null, then this doesn't exist anymore. If this doesn't exist anymore, you know, basically the reference, that one reference count is gone. So the reference count becomes 0, and therefore that location is deallocated. Again, come back to here. Remember, the reference count for person instance was 1. So if you break this strong reference in here, the RC for this person instance becomes 0, and it gets deallocated by Swift. Once this one gets deallocated, any weak reference to that location also become nil. So here from person to this memory, there's a weak reference. Of course, this memory is not available anymore. Like, I mean, it's been deallocated. So therefore, you know, the tenant will become automatically nil. So this one become nil right now. So the reference count for the apartment is 1. And as long as you put the unit for A equal to nil, then you also break this. Reference from here, and therefore the reference count for this one becomes 0, and therefore it's also get deallocated by the Swift compiler. So this is how you can fix this problem of a return cycle or reference cycle. So this is how a weak reference is helping. So unowned is also similar to weak. So the only difference is that, you know, just look at this example again. Other than that, the mechanism is exactly the same thing. So unowned is similar to weak, is creating a reference to another instance, but it doesn't add to the reference count of that instance. But, you know, for instance, you know, between the customer and credit card, you know, the credit card doesn't exist for sure, as long as the customer doesn't exist. So, you know, it's not like a debit card. Debit card is different, right? For instance, when you go to the bank, you know, they have already printed so many debit cards. So you can quickly in the branch, you can change your debit card. For example, if you have lost your debit card, you can go to the bank, hey, can I get a new one? And they give it to you. Your name is not on the card, right? Usually. But when it comes for credit card, you cannot get a credit card right away. Credit card takes time. It says, we got to post it, we got to mail it to your address in 3 weeks, because a credit card is only created for a person, right? So that means, you know, if the person doesn't exist, the credit card doesn't exist. This is when you use unowned as opposed to weak. So this situation is different from apartment and unit, right? Which one of them could be living without the other. But here, you know, the customer always live longer than the credit card, or they die together. They die together. So in this situation, you use unowned. Other than that, there is no other like a major difference between unowned and weak and how it works. So the same thing in here. Again, when you assign John, you just create a strong reference from John to that location, and from the credit card to the customer. So here you have another strong reference. There's an unowned reference in here. So when you break this one, the reference count for this one becomes 0. Then this strong reference is also broken. This unowned become nil because this location is already deallocated. So therefore, the other one also get deallocated. The reference count for the other one becomes 0, and also this one gets deallocated as well. So I'll continue with this. I'll remind you again next week about this weekend unowned if needed, and we'll continue with, and we'll see how it also works when it comes to the relation between a closure and a class. So you define usually a closure as a property of a class, right? And so how this return cycle, again, the same mechanism in there. And but it's good to see how it works when it comes to the closure and also in relationship with the class. And I just want to remind you, remember Venmo software is going to do also some live coding. Remember when we were working, when he was creating those like outlets manually for you with a storyboard, remember you set all of them to be weak. So this is the same thing, the same mechanism in here. You don't want to create a strong reference between the view controller and those like a UI element on the storyboard. So that's why all of those outlets are defined weak. Okay, so any question? Just quickly, just give you some introduction about how memory management works. So the few things you need to know: what is arc, what is a reference count, what is a return cycle, and how the return cycle is resolved using unowned and weak. So we'll continue with this topic again next week. Does that make sense? Any question?
So not a question about this, but I'm wondering if before the end of the class today, we could just kind of clarify exactly what is required from us by the end of the course.
Sure, okay, we can talk about it.
That would be really great. And just so that you know that normally with part-time courses, the final exam